Alright, today we're going to be looking at the properties of real numbers, and these are basically the rules that govern everything we do in math. They tell us how numbers and terms are going to interact and what sort of moves we're able to make and those that we cannot make. Our first rule is the commutative property, and this is probably one that you are familiar with. The commutative property talks all about the order in which we do things, and this works for addition and multiplication. Inside the word commutative, you'll see the word commute. So when I come to school in the morning, I commute from home to work, and then I switch places when I commute back at the end of the day. Commutative property says that the order in which we do addition and multiplication does not matter. So if I do A first and then I add B, I'm going to get the same answer as if I do B first and then add A. Same thing when we multiply. That order does not matter. And this works when we have 2, 3, 4, or more terms. So if I do A times B times C times D, that's the same thing as C times B times A times D. That order isn't going to matter there. The next property that we have is the associative property, and this talks all about how numbers associate or how numbers group together. When we use that grouping symbol, usually it's going to be parentheses, but sometimes you'll also see brackets to indicate that grouping. And this says that when we add or multiply, it doesn't matter how the numbers are grouped. So here we have A and B together, and then on the other side we have B and C grouped together. Notice that the order is still A, B, C, and A, B, C. The order remains the same, and the same holds for multiplication. The reason that this works is because if we think about our order of operations, we have G, E, M, D, A, S. That grouping symbol always comes first. So when we change the grouping or the association of terms, we're just changing which two terms are added or multiplied first. And again, because addition and multiplication are commutative, we're allowed to do this. We're allowed to change this order by using those grouping symbols. But again, note that here we have 3, 2, 4, and 3, 2, 4. The terms stay in the exact same locations. Next we have the multiplicative property of 0. This is one of those obvious ones. Anytime we multiply by 0, we get 0. We're saying that we have 0 groups of A or 0 groups of 8. That means we have absolutely nothing. This is only for multiplication, so you'll see the word multiplicative in there. Anytime you multiply by 0, you get 0 as your answer. Next we have the identity properties of addition and multiplication. And it's important to be specific, so you'll say identity property of addition or identity property of multiplication, just so we can be as precise in our language as possible. We know that when we add 0 or when we add nothing to a number, the sum is that number. So we start off with A, we add 0, we finish with A. We start off with 8, we add 0, we finish with 8. Your identity is who you are, so never change, stay being you, and we do that with this identity property of addition. Same thing when we multiply by 1. So 1 is the identity for multiplication. We want one group of A or one group of 7. We multiply A by 1, we start with A, we finish with A. Same thing down here, we start with 7 and we finish with 7. So whenever you see the same thing on both sides of the equal sign and you're adding 0 or multiplying by 1, that's going to be your identity property. Next we have additive inverse. Break it down a little bit. Add here is our adjective for addition, and then inverse is our fancy math word for opposite. So when we talk about additive inverse, we're talking about numbers that are opposites. When we add them, we get 0. To get the opposite of a number, we take it and change its sign. So if we start with positive 6, the opposite is negative 6. We know that numbers are opposite because they sit equidistant from 0 on a number line. So if I count 6 units to the left, we'll be at negative 6. If I count 6 units to the right, we'll be at positive 6. This is like saying 6 plus negative 6. I take 6 steps forward and then 6 steps backwards. I'm going to finish up exactly where I started. So anytime we add an opposite, we're always going to get 0. Next we have the multiplicative inverse. So again, we're multiplying and we're dealing with that opposite. Except now we're trying to get back to 1. So anytime we do the inverse property, we're always trying to get back to our identity. So the identity for addition was 0. The identity for multiplication is 1. In order to do this with multiplication, we're going to take whatever number we're starting with and multiply by its reciprocal. So if I start with something like A, we're going to pretend there's that hidden 1 in the denominator. Then I take it, rotate it around, flip my numerator and denominator to get my reciprocal. Then we multiply, we get 1. So if we take 10 times 1 over 10, we've got our 1 here. We can reduce by 10 on both corners, and we're going to get 1 as our product. This also works for negative numbers, so the reciprocal of 1 over negative 7 is negative 7 over 1, but usually we won't write this over 1, so don't be fooled if you don't see that. This also works for other fractions, so if we have 2/3, its reciprocal would be 3/2. We multiply that together, and we're going to get 1 as our product. Next we have the properties of equality, and these are the ones that seem kind of obvious, but these are actually really important. The first is the reflexive property, and this says that any quantity is equal to itself. I call this one the no-duh property, because of course 7 is equal to 7 and a is equal to a. Another important application though is if we have xy on one side is equal to xy on the other side. It's important to note again that the order does not change from left to right. Within the reflexive property, we have one equal sign. So 1 equals for reflexive. This is going to be important to remember. Next we have the symmetric property. Symmetric property talks all about symmetry. So if we look down our equal sign, we have a equals b and b equals a. We have to have the word and for symmetry, or maybe sometimes a comma, but then terms on the inside will match up. So we have b and b, and then along the outside, we have a and a. Think about the symmetry as a transformation or in a butterfly. Every point on the left matches up with one on the right. They're going to be equidistant from the axis of symmetry in the middle. When we look at symmetry, we have two m's, and every time we're talking about the symmetric property of equality, we have two equal signs. So we have to be able to draw that axis right down the middle through the word and. Notice that when we had our second example here, the 6 plus 3 stayed in the same order both times. As soon as I flip those terms around, then I'm starting to look at commutative property. Next we have the transitive properties. This is where we're looking at three different quantities that are all equal. So if I have A, and I know that A is equal to B, but I also know that B is equal to C, then I can kind of cancel out the middle here, and we can say, well, I must know that A is equal to C. Transitive property is always going to have three equal signs. Those of you that are kind of familiar with Spanish, we know the word for three in Spanish is trace. Trace starts with TR, transitive starts with TR. So we can use that to remember that we have three equals in the transitive property. There must be three separate equality statements. The next property of equality is substitution, and this is one that's kind of so obvious it's very easy to miss. We use this one all the time. So our property here is that any quantity can be substituted for its equal in any expression. We use this when we simplify using the order of operations. We use this when we use a function rule to find a new value. We use this when we evaluate expressions, just like we did before. We're given our replacement value of n equals 15. We know now that n and 15 have exactly the same value. So that means that anywhere I see an n, I can take it out and put 15, and the value of my expression stays the same. The other example that we see is something like this, 3 plus 5 equals 8. Anytime we do any sort of calculation, we're using the substitution property. We're taking out the 3 plus 5 and replacing it with the 8. So if I'm working on simplifying an expression and I have 2 minus 3 times 4 plus 6, and I want to simplify this, my next line of work, I'm going to take out the 4 plus 6 and replace it with 10. As soon as I do that, replacing the 4 plus 6 with the 10, I'm using that substitution property because we know that those two are equivalent. The last ones that we have are the properties of equality that let us solve equations and inequalities. And these are what let us kind of take those different steps to isolate variables. These properties all say the same thing, that if I start with two equal quantities and I do the same thing to both of those quantities, the equal sign still holds. So if I add to both sides, I'm still good. If I subtract the same thing from both sides, we're in good shape. If we multiply both sides by the same value, we're still equal. And if we divide both sides by the same number, we're still equal. These are the 4 steps that we're going to use a lot as we start to move into solving equations and looking to isolate those variables so we can find out what those missing values are.